So here's a little bit of background about Java. It was started at Sun Microsystems, which was a hardware company that produced medium-sized computers, and it's considered a high-level programming language because it's human understandable. Low-level languages are more machine understandable. Java is now owned by the Oracle, which is a database company. Syntax is pretty much the structure of the language that needs to be followed by programmers in order for the program to be well understood and compiled and not have any errors in it. There are certain keywords in the language that can't be modified or redefined. So these keywords are things like print line, which always mean and do the same sort of thing, and you can't ordinarily overload them. You can't ordinarily write your own version of it. This idea of step-by-step programming typically means that as you write code, it starts at the top of the page and executes each expression line by line. The lines are ended by semicolons, so it reads a block of code and it starts with the first expression, does that. When it's finished with that, it goes to the next one, and then it goes to the next one. There are ways of creating structures that cycle, that repeat themselves for a certain number of times or until some condition is met. We'll talk about that later. Right now, today, we just want to get something that tests out our setup and tells us that we in fact have a version of NetBeans or whatever IDE we're using that works, and typically that's just to do hello world and then look for hello world as output. Right now we're writing command line applications. We're not using any kind of graphical user interface. So here we are line by line. This is in fact the name of the file. The class name and the file name have to be the same. The file name is going to say hello world.java, and so keep that in mind. You can't have spaces in this name, and again, you can't use those reserved words. You can't call a class println. There needs to be a main. Actually, this thing's called a method. So it's a block of code. The blocks of codes are the things inside of the curly braces. So this is the outermost block of code. It's a method called main, and it's called automatically when you call the program itself. So when the application starts, it looks for main, and then it goes to the first line in main, which here says that we're going to print hello world to the screen. That's what print line does. Notice hello world is a string, meaning that it has double quotes around it. You need to put in the double quotes. That's the thing that tells it that it's a string, and it's something that we want to put on the screen. Here we're just, you can pretty much follow this. This tells you how we're creating the new project. So there are a lot of things that you can do with NetBeans, but the thing that we want to do is create a command line application. And so you launch NetBeans. It's an IDE or an integrated development environment. In other words, it has not only can it compile your source code into some kind of executable code, it also has a lot of features on the text-based part of it that give you hints as to what the language looks like and how the language should be used. Think of that as being sort of like a really advanced spell checker or grammar checker. So it checks your syntax, and it gives you hints. It anticipates what it is that you're trying to do, and it shows you how to use different built-in methods. So use the new project method wizard. Use the new project wizard, and pretty much it's going to create a directory for you. It's going to create a project for you. It's going to put the file in a directory name for your project, and so forth. And there's a little information here. These, if you have the actual version of this PowerPoint, you can click on these and get information about installing NetBeans from Oracle and so forth. So here would be the next screen that shows you that you are in fact creating a Java application. You would supply the name like assignment 1 or whatever you want the project to be named. And here it's going to the next, make sure that in the next screen, make sure that you have create main class clicked, and it will automatically do that for you. That's why it's called a wizard. You don't have to, it's cutting down on the amount of code that you have to enter. And then you find a place in there where you can actually put in system.out.println. This says that we're going to put something in standard output, which is the screen. We're going to print a line. The print line, the ln, means that it gets a carriage return at the end, so it'll be on a line by itself. More on that later. There are other ways of putting comments into your code, but these two slashes, two forward slashes are comments, and so they're not part of the code. They're things that you're adding to give yourself instructions, or the next person that looks at the code instruction. I'm going to ask my students to put comments in the code just so that I know that they understand what the code is doing. And then when it runs, you get hello world and there were no errors. However, if you'd made a syntax error, it would have shown up. In fact, it most likely would have shown up before you even tried to compile and run the program. But so Control S will always save your program. If there are any errors in your syntax, you'll get a message. Normally you don't want to run the code if it has errors in it. You can also see these red error icons to the left of the line numbers. They look like a red stop sign with an exclamation point, and if you hover over them, it'll give you hints to the solutions. Here's a little bit about how println works. You'll have to excuse me for the capitalization on println. It normally doesn't look like that, so it uses camel case. Well, it doesn't use camel case. I'm sorry. This thing up here is capitalized because that's what Microsoft PowerPoint does in this particular slideshow. But if you look on the next slide, you'll see that it's really all lowercase and not all uppercase. But anyway, what's interesting about this slide is that there are some sort of intangible things about just printing text on the screen. Sometimes you want to have a carriage return or a new line, and if you don't use println, in other words, println is going to give you one carriage return at the end. If you want multiple carriage returns in the same print statement, you can, any place you insert the \n, it'll give you a new line. Likewise, if you want tabs, you can use a \t, which corresponds to the tab key. The \n, of course, is the enter key. But since we're using backslash as a special character, if you want to print a literal single backslash, then you have to do what's called escaping it by putting in two backslashes. So two backslashes become equivalent to printing one backslash, because we're indicating that we're not using the backslash in a special way. And likewise with the double quotes, since we use double quotes as delimiters, they don't actually show up, as we use double quotes as delimiters for strings to indicate that this thing is a string of characters. It has a quote at the front, quote at the end. We have to escape them if we want to print a literal quote inside of the string. So if we just want the quote character, likewise we have to escape that with the backslash. You can do what's called concatenating or combine pieces of text with the plus sign. So we'll see examples of that in the next slide. So here, this is a literal string, hello world. This is another literal string, howdy. Here we're printing out a tab after we say this is a tab, so that \t will not show up. What will happen is there'll be a double quote, I believe 3 spaces for the tab, and then the period. Of course, none of the double quotes show up either. Here we want to print hello, which is one string, and then concatenate it to, you notice it's a space, so there's a space after the next double quote, world, and that would print hello world. So the plus sign adds or concatenates the strings. Likewise in the next. Okay, so variables. One of our first concepts here is, what is a variable? A variable is a place to store something. A variable can be a place to store a string, some characters that have double quotes around them. It can be a place to store an integer like a 7. It can be a place to store a floating point number like 3.1416. Okay. So they're called variables because we can set them to some number. Like we can set a variable called pi to 3.14, and every time we want to use 3.14, we can just put in the name of the variable. We can just say pi. So we can multiply 7 times pi, and the output would be a little bit more than 21. In other words, 7 multiplied by whatever value we put in as pi. That's very nice for things when we're going to use them in multiple places. But if it's just an ordinary variable, we could decide, and this may not be the best programming practice inside of the same program, but we could decide, well, we would rather have 3.1416. So we can change it. It is a variable unless we specifically tag it as being a constant. But an ordinary variable can be reset. In other words, an ordinary variable is just a memory location with some type. Java is a typeful language, so we have to tell it what type of thing we're going to store. So are we storing a string, are we storing an integer, are we storing a floating point number? And then that's what we're going to put in there and use it accordingly. And the program knows what to do with these things. If you give it 2 integers, it does integer math. The plus sign means to add if they're numbers. If they're strings, the plus sign means to concatenate. So the type really is very important to keep track of. So if you concatenate 2 variables that are strings with a plus sign, it puts the 2 strings together. If you add 2 variables that are integers with a plus sign, it adds the values. Variables therefore have a type, they have a name, and they have a memory location. You can only have one value in a variable at any particular time, but the value can be changed. So this is a little bit different than math. There are some rules about variable names. It must start with a letter or an underscore, and it can only contain letters, digits, and underscores, and variables are case sensitive. In other words, you cannot begin a variable name with a number. So 42 as a variable name is certainly not permitted, and these other examples are all not good. Don't put any spaces in variable names. Not good. You have to declare the variable. In other words, it's going to allocate some memory and record what type of a thing is going to be stored in that memory slot. So the declaration says, you know, give me a variable, it's going to contain this kind of stuff, and it may or may not get a default value. It may or may not have a value. Typically you want to initialize it or put the value in pretty soon. So here are your types. Variables are integer, which is it can be either positive or negative, but it does not have any decimal points. Double, which is your floating point number, your number that has a decimal, a fractional component. Booleans are values that are either true or false. We use those to test conditions. We test to see if var1 plus var2 equals 4. If it is, then we can do something. If it isn't, a char would be a single character, like a T or a Z. Variable declarations, and here are some examples. Int means we're making an integer. Double means we're making a floating point number. Char means that we're making something that's a character. The semicolon at the end ends the declaration. So we could also initialize it by putting a value to it. Before you use a variable, it must have a value, or you get some sort of an error in your program. It will use it and produce an error and say you've got to initialize it. You can't use it without initializing it, in other words. And NetBeans is going to catch that for you. So you can initialize it when you declare it, as in int numVals equals 10, or you can initialize it as int numVals semicolon, and then the next line say numVals equals 10 semicolon. So you can do it all in one line, or you can do it in 2 lines. You can choose which way you want to do that. So here's Hello World again, and we've added something to it. We said int magic points equals 100, and then we're printing out our string, number of magic points, and then we're also inside the string concatenating a variable. And the variable is going to automatically be converted to a string before its output. This is the little magic that's done for you by the compiler. So even though right now it's an integer and its value is 100, when you put it inside of a print line statement and concatenate it to a string and so forth, it's going to output the character 1 followed by the character 0 followed by the character 0. So it will output it as a string to the screen, which is pretty much the only thing that can go on a screen. So you don't need to worry about that. But variables get upcast, so to speak, or they get converted, is a better way of saying that. They get converted into a string when they're printed on the screen. So on the way out, variables get converted to whatever's appropriate to display them. On the way in, you're going to have to do type conversion. You're going to have to be aware that what's coming in is here 1 0 0, if you're doing this from the command line. We're not doing it from the command line here. We're actually typing it into the program, so there's no conversion necessary. But if you take user input, then there may have to be a conversion that takes place from what comes off the keyboard. Here, it's already in the program because we typed it in, so I hope that's not confusing. So print line will print the variables. You don't need to put the variable in quotes. In fact, you don't want to. If you do that, then it just prints the name of the variable instead of the value that's stored in the variable. Anything that's inside of a double quote is called a literal. So if you put, in the last example, if you put the name of the variable in double quotes, it's going to print the name of the variable. If you leave off the double quotes, it's going to print what's in the variable, what value that it has, the 100. So these are called bare words. So when the program sees a bare word, it assumes that it's a variable name. So you need to keep this in mind. Double quotes, literal string, printed exactly the way it is. Bare word, this is something that we can do math with or test for true or false. It's a variable. It will get converted to a string if you put it in a print line statement, so you don't need to put the double quotes. If you leave the ln off in print line, it just prints without the new line character. Then you'd have to put in a \n. You'd have to literally put in the new line. So here's hello world again. We're going to have magic points and hit points. They're all integers. They are declared as int. There's your variable name. There's the value that's stored in it. There's the type. There's a variable name. Value stored in it. We're just going to print this, and then we're going to print line that, and then we're going to print line this using concatenation. Then we're going to print line that, and then the question becomes, well, how many lines are we going to get here? What's going to come out? What's going to be printed? So clearly these first two things are going to be on the same line. So it's going to print number of magic points, and then right after that, in the output, it's going to print the value of magic points. It's going to print the 100 because we used print here. And so in a real way, it's a lot like doing this. So just don't worry too much about it. But at this point, you get 1, 2, 3 lines. This is not on a line by itself because we didn't put a \n inside of the double quotes. The \n would have to go inside the double quotes if we wanted a new line there. So, not on a line by itself. The print statement is not on a line by itself. The print lines give you the new line characters, so they're on their own line. Carriage returns. So Java starts executing at the first line. Each line is executed until it reaches the final closing curly brace. Notice that these are called curly braces. They come in pairs. There's one at the beginning of the block of code. So there's a main method, then it's followed by a curly brace, and then down at the end there's another curly brace. And that's where the code quits, is when it sees this closing curly brace. So a single line followed by a semicolon is called a statement, and a collection of these single lines, a collection of these, actually they can be spread across multiple lines, but don't worry about it right now. A collection of these multiple statements is called a block of code, and if the block of code is being used as a method, then it's called a method, right? There are other blocks of codes. We'll see those later. So sometimes we want to take input from the keyboard, so instead of using system in, system out, I'm sorry. Instead of using system out, we use system in. And this is a bit involved with Java because Java wasn't originally a language that was working on the command line. It had system out so that it could do error reporting and so forth, but it wasn't typically taking user input from the command line. It was typically going to use a graphical user interface with little text boxes and buttons and so forth. But as time went on, a few years back, it was decided it should also be able to take user input. So we now have a system in, and in order to use a system in, you have to create something called a scanner object. Again, this is a built-in class. A class is, you can think of as something that has a bunch of built-in functionality so that you don't have to reinvent the wheel every time you want to take user input. You can just create a scanner object, and it takes a while to get used. Let's take a look at the next slide. So here's a complete example. We've created a scanner object. I'm sorry, we have to do the input before we create the scanner object. So here we're creating scanner input equals new scanner system in, right? But even before we can do that, we have to tell Java, scanner is not a built-in part of the Java language. We have to import it. We're importing it from what's called the library. We're sort of checking it out. So it's not automatically there. We have to say, no, go check it out, and we're going to use it in this namespace or in this particular code that we're writing for our application. So we have to do an import. We have to go get the scanner class. Okay, a couple of notes about the use of scanner objects. It has to do with white spaces being spaces, new lines and tabs. If we're doing an assignment and we're assigning a single value that's input to a single variable, then the input is going to end whenever we see a space or a tab or a new line, the enter key, in other words, in the input. So essentially, scanner is reading in one word at a time. On the other hand, once you've prompted the user and set up a scanner object like input to do the input, then the program execution is going to stop and wait for you to input something, and it will not continue until you actually input something for it to do the assignment with. So, and you need to remember to do the import Java1 scanner and to put the semicolon at the end of the import. So it says java.util.scanner semicolon. Without the semicolon, you get an error and the program doesn't compile. So we know about the double forward slash as being a single line of comment that excludes the text that comes after for one line from being part of the source code. And we can also comment multiple lines, as you see here, with a forward slash, a star, and then multiple lines of comment and a star and a forward slash. There's a third way we'll look at later for creating Java documentation that specifically to Java. Here's a commented example. It says we're going to set up the scanner to work with user input, single line comment. Then we do that, and then we say we're going to initialize the number of magic points to 100, and then we do that. And then we have a multiple line comment that initializes the hit points. And then we create a variable of type integer called hit points. We prompt the user to enter the number, and then we do an assignment. We say hit points equals input.nextInt. NextInt means that we're going to take the characters that are input and convert them to an integer. And keep in mind that on assignment operations, there needs to be a type match from the left and the right, and we have that here because hit points is declared as an integer, and whatever's input is being converted to an integer on the right hand side, so there's no type mismatch on the assignment operation. And then down at the end we show a little bit another example of outputting to the screen that tells us that the bare word hit points gets automatically converted to a string when it's concatenated on the way out. So there's an automatic type conversion from whatever to string on the way out, but on the way in, the string of the characters that are input have to be explicitly converted to integer, double, or boolean. Or if you do want to just take them in as characters, you would say input.next or next line, depending on whether you're taking in one word or one line. And so our wrap-up says that there's a difference between system out print line and system out print. Anything in double quotes is printed as a literal word. So if you put those double quotes around a variable, it's going to print out the name of the variable instead of the value that's stored in the variable. We use scanner objects to get user input from the command, from the keyboard. And I want you to include comments so that I know that you understand what the code is doing. So thank you very much, and that ends this particular lecture.